Hi, I'm Steve Jones. I'm going to explain briefly what enriched uranium is. Uranium is found naturally in three different forms. All are radioactive, so don't think that there's a stable form. There is no stable form of uranium. All are radioactive: uranium-238, uranium-235 and uranium-233. Now, the most common one is uranium-238. 99.3% of uranium is uranium-238. It contains 92 protons and 146 neutrons, and of course 92 electrons if it's in a neutral state. So, uranium-235 is slightly different. It still contains the 92 protons, of course. That's what tells us it's uranium, but only 143 neutrons, and uranium-233 with 141 neutrons. We can forget uranium-233. It's like uranium-235, but there's so little of it that it will never be of any use in for practical purposes. Uranium-235 is different from uranium-238 in the way it behaves when it is hit by a neutron. Here, a neutron hitting uranium-235 atom can produce what we call fission. And fission is basically, it's a term that comes from biology when a cell divides. A cell divides into two equal parts. Well, fission means it's got two big lumps. So the uranium-235 doesn't just spit out another particle, it actually falls to bits into two pretty hefty lumps and chucks out a pile of neutrons. Well, maybe for each neutron coming in, maybe 3 neutrons coming out. Most of these neutrons disappear into the air and don't cause a problem. But what you can do with this reaction is you can produce a chain reaction. And the chain reaction is where these neutrons coming out hit other uranium-235 atoms and therefore produce further fission reactions. Considering this reaction takes 10 to the minus 9 seconds, that's 100 millionth of a second, you can imagine these reactions taking place one after the other produce a huge amount of energy. This in itself produces a massive amount of energy, much more energy if you get a lot of reactions very, very quickly in a very short space of time. The chain reaction, therefore, will produce a huge bang, and hence you've got your atomic bomb. But the problem is that uranium is not uranium-235. Less than 1% of it is this. So actually, less than 1% of these neutrons will produce other fission reactions, and therefore it'll fizzle out. Nothing will happen because most of these neutrons go on this reaction, where they're absorbed by uranium-238, and produce plutonium-239, which does undergo fission, but under different circumstances, and basically this causes the whole thing to fizzle out. So what is enriched uranium? Well, the answer is pretty simple. You have to make sure that the amount of uranium-235 is much higher in proportion, in percentage, than the 0.7% it is at present. It doesn't have to be approaching 100%. But it must be much higher, maybe 30-40% at least. Once it is at that kind of level, you can get enough of these neutrons to produce reactions, to produce this chain reaction. And there are other things you can do to the components of what is a bomb to produce this reaction. Now, the chain reaction can be controlled by absorbing neutrons. You know, if you absorb them, it'll stop the reaction. And therefore you can get the chain reaction but control it, and that's what we do in a nuclear reactor. We have a fission reactor, a fission process, but we have something which controls the neutrons so that we can very finely tune it so it just produces enough reactions to produce a very hot body. And the hotter it gets, the less reactive it becomes. So you can produce a chain reaction and control it. But you still need enriched uranium, that is uranium with a higher percentage of uranium-235. So there is the answer to your question. What is enriched uranium? It is uranium which has a higher percentage of uranium-235 than natural uranium.